this is our turning section, and we can machine parts here from 300mm diameter down to 0.3 of a millimeter diameter. Here we're machining the bells that are used on our 3-train chiming skeleton clock. We start off with a casting, and it took us a long time to find a company in Yorkshire that could cast the bells. It's a bell material, 80% copper, 20% tin, which gives a nice tone to the bell. Jack, my nephew, is machining the outside profile, after which he will test the bell for its pitch and then make a correction to the pitch. And he corrects them by hand.
So this is the bell I've just taken off the machine from the workshop, and it's 1 mil big in diameter. So I'm just going to test what tune it's got now. So we've got that reading at an A-30, which is 1700 Hertz. And what we're wanting is 1046. So we're going to have to take quite a bit off this. These two are already finished. This one will need papering down. I'm going to paper down the top edge on a peg until it reads the right note.
When we first started making bells, I was told that there were only 6 people in the UK that could tune bells. Well, we have 2 people in this company who can tune bells. So here we're making the centre pinions for the 3-train chiming skeleton clock. We use predominantly stainless steel for the pinions. Stainless steel's been hardened, so it's got a toughness about it and it's perfect for pinions. 3 operations. This is the first stage. We machine this diameter here. And then the final part, there's another 2 operations to get the pinion to this state. So here we've got, this is where the minute hand will go. Teeth will be cut on here, and this is the back pivot. And the way that we make them in small quantities, only in 5s. And this diameter is pretty much perfectly parallel. So here's where we manufacture the Fusee chains. Most of our clocks have a Fusee chain. Start off with stamping out the outer links, and each of the 2 holes are then countersunk, a very tiny countersunk. In each chain there's some 512 outer links, 256 inner links, which are heat treated, and 512 pins. We don't actually manufacture the pins. It's one of the very few parts we don't make, mainly because there's thousands of them. Once we've got all the parts together, the first part of the process is to make up a little sub-assembly, which is just an outer link and 2 pins. And we loose crimp the pins into place. So here Jack's crimping the pins into the outer link, and we make up all the sub-assemblies. Then what we will do is we will assemble the little sub-assembly along with an inner link and an outer link, and we'll just loose crimp it into a short section. So there's the short section. The inner links are heat treated, and once we've got the short length of loosely crimped chain, we then rivet the pins so that they go into the countersink. We have to be very careful with the riveting. If we rivet too hard, they can tighten up the chain. But once they're finally riveted, we then file and paper all the heads off the short lengths. And the final part of the process is just to join all the short lengths together till we get a 6-foot length of chain. So here we are in the polishing department. This is the most labour-intensive part of the process. All the parts come into here as a kit, so when they've been machined, they go back into the stockroom and they're kitted into sub-assemblies, generally sub-assemblies for each clock. It's very easy to destroy everything that we've done in the machine shop, so there's a lot of care and attention at this part of the operation. Every crossing on the wheels, these have been machined on the wire erosion machine, but every crossing is hand finished to a mirror finish. And then the faces are finished. These faces have been roughly prepped and the crossings are about to be polished. Once the parts are polished, we will do a cleaning and an inspection. So we clean the parts, inspect them. If there's any blemishes or faults that need correcting, then they'll be corrected, cleaned again, and then they're ready for electroplating.
After the parts have been polished and cleaned, they're then inspected and brought down here for electroplating. And basically what we do is we do a nickel plate as the first coating, and we try and aim for about 10 microns on the plates and about a 5 to 7 micron coating on the gears. Prevents buildup of the nickel. And we do this by basically, we know that the solution plates 1 micron a minute when it's run at 5 amps per 100 centimeters squared of area. So basically every component that comes through here, we have the surface area. And when we rack them up, we add the surface area up and we can then apply the correct current. And then obviously by the amount of minutes gets us an approximate coating thickness. And after the nickel coating, it's then basically the parts are then rinsed and then they will then go into the gold. If the parts are going to be platinum plated, we then plate on the platinum on top of the gold. So if there's a platinum part in the clock, it will have a flash of gold underneath it.